This is the solution for number 57. So let's take a look at what number 57 says. 57 says, below is the data showing the number of children served by the foster care system in the United States each year from 2010 to 2019. Again, we'd like to use technology to create a scatter plot for this data. So I need to put either the data into Desmos or my graphing calculator. We'll first go ahead and start with in Desmos. So we're going to go into Desmos. You can copy the data straight into it, which is nice. Notice when I did this, it fitted for what it thought would be a best fit for this the axis. If you'd like to switch it, you can, but we don't really need to. We just need to kind of look at what shape it is. And this looks like it's going down, up, and then coming back down again. So that kind of makes me think it's periodic. So what we need to do is we need to look to see what periodic shape looks like. So we're going to go into the calculator. Into the textbook. Sorry about that. And periodic is y is equal to a times sine of bx plus c plus d. Notice that bx plus c is in parentheses. So we need to make sure we remember to put that parentheses in Desmos. Again, you want to do y sub 1. So you can do y and then type a 1 in and it will automatically do the subscript. Then we want to do tilde, which again, the tilde is next to the number 1 key on the top row. And then it was going to be a times the sine. Desmos knows what sine is, so it will automatically make it into a little bit different. And then we're going to put a parenthesis in, and it was going to be b times x plus c. Close that parenthesis, and then plus d. But again, it hasn't done anything because it doesn't know what x is. It knows what x1 is. So we need to put the subscript of 1. So put a 1 after the x and automatically makes a subscript. And then it kind of follows that. And you can see this looks pretty good at actually following this data. When I look at this, I see here's my parameter. Here's my A, here's my B, here's my C, and here's my D. And here's my R squared value. So I get all of that directly from Desmos. If we want to look at how we do this in the calculator, we'll go into our calculator. So I'll bring the calculator up. Again, what I need to do in my calculator is put the data set in first. So we're going to go and hit the stat button. That will get us to the edit. So we're going to do number 1, which is edit. Again, if you have something in that column, which we do, we want to clear that out. So you go up onto the name, hit the clear button, then hit enter, and everything will go away. And then you can go ahead and type in your data value. The 2010, 2011. Looks like it goes all the way up to 2019. You just type that data in. Then we're going to go to Y to L2 and we'll type in the other values. So 663, 1, 2, 3 zeros. And then 638, 1, 2, 3 zeros. And then 630, 0, 0, 0. And then 633, 0, 0, 0. 645, sorry, 646, 0, 0, 0. 663, 4006. 680, 433. 685, 007. 686, 151. And 672, 594. And then you want to go ahead and turn on that stat plot. So we go into second y equals to get the stat plot. We're going to turn that one on. So go into number 1. You want to turn it on by hitting enter on the word on. Default again is your the dot plot, then your list 1, your list 2, your mark, and your blue. And again, you may not have blue. Then you want to go to zoom. and you want to pick number 9, which is zoom stat. You can either arrow down to number 9 and hit enter, or just press the number 9 key, and I'll plot it up. And you look at this, it looks very much like a periodic graph again, because it goes down, comes up, and comes back down. I then want to create the graph, the equation for this. So I'm going to go to stats, go to the word calculate. I'm going to go down. If your calculator doesn't have the sign regression one, then you'll have to use Desmos, but this one does have it. So I'm going to hit enter. The iterations, just leave it at the default of 3. You have a list 1, a list 2. Again, I would like to store that. So I'm going to go to the VARs button. Once I'm on the store regression equation space, I'm going to hit VARs. I'm going to move over to the Y VARs. I'm going to type number 1 for function. I'm going to type number 1 for the YE1. I'm going to move down to the word calculate. I'm going to ask it to calculate that. Again, the calculator isn't going to give you the R² value for regression, sign regression. It does it for other ones like exponential and linear, but it won't give it to you for this one. So we'll have to use Desmos for that. So you may want to use Desmos anyway. So here's my equation. Now I can go ahead and type this in or write this in. And I'm actually going to type this because I don't need any great math symbols here. I can actually just type it straight as it is. So y is equal to a, which is 29,183. Why just call it 184? So 29,184. Sine of my b, which is 0.64, x plus c. My c is 0.077, let's say. And then I'm going to add to that 69,659,623 by round. So there's my equation. And that's my regression equation, my model. If I go back to Desmos, I can find my R² value. It's 98.94. So if that's the next question it asked me in here, it asked me determine the R² value for your model and interpret it. So it was, again, going back to Desmos, it is 0.9894. So we can type that in here now. And my R² is 0.9894. The interpretation is that 98.4% of the variability in the Y variable, which in this case was number of kids and foster care, is explained by the model, which in this case, the model only involves time. So you could just say it's explained by time. You probably should have written down somewhere that Y is equal to the number of kids in foster care at time t or year t. That way you know what your variables were. The next thing that you're asked to do is, let's look to see what the homework asks us to do now. This says use your model to estimate the number of child served in the foster care system in 2020. 2020, that's my input is 2020. And then we are asked if we should trust this predicted value. So we're going to go ahead and figure that out. The nice thing about the calculator is because we already put the y equal to in here, we can actually use that y equal to, going back to the main screen by doing second quit. Then go to VARs, over to y variables, number 1. That puts y1 on your main screen. Then remember function notation is f of. Then you just did type 2020 inside this parentheses, close your parentheses and hit enter. So it will tell me exactly what that value is. So it tells me in 2020, there are 65,044.13, and I rounded it off to 1 because I can't have more than, I can't have a fraction of a children in foster care. This value of 2020 is outside the original range of data. It's not that far out of it. So you should be careful, be leery of extrapolation. But we're pretty close, but we're not that much outside of extrapolation. But 2020 is close to the highest data, the highest input value. So it may be okay. The next part of the problem asked me to think, do you think it's reasonable to use this model to predict the number of children in the foster care in 2050? And that one I would say no, because that really is extrapolation and that's way beyond where we want to be. So I would say 2020, 2050 is too far from 2019. And so the extrapolated value is too unreliable. Something like that. You could come up with your own words. Ignore the fact that I spelled those wrong. So that's how we do that problem.